So I'm Candace Patterson, and I'll be speaking on behalf of the AnVIL with Stephen Mosier. So I just wanted to do a kind of brief overview of AnVIL and what it is. So AnVIL is a cooperative agreement between two parent awardees, the Broad Institute and Johns Hopkins University and NHGRI. We have two program directors, Anthony Philippakis at the Broad, who's also our Chief Data Officer, as well as Mike Schatz at Johns Hopkins. And then we have project management support team that includes myself, Stephen Mosier, Natalie Kucher, as well as a few co-investigators that include Rachel Liao. Okay. So what is AnVIL? AnVIL is a cloud-based data repository and analysis platform that was funded by NHGRI. And it was built to provide a cloud-based infrastructure to allow for data management and storage in a secure environment. It hosts many genomic data sets from large-scale NHGRI programs, such as the Center for Mendelian Genomics, 1,000 Genomes, and a few others, as well as providing a collaborative compute environment for researchers to come together and share analyses and tools. Okay, great. So the main goal in building these cloud-based data repositories is really to invert the model of genomic data sharing. So for those of you who have used dbGaP, the database of genotypes and phenotypes, the way that was set up was that researchers would apply for access, be granted access to the files, download a copy to their own on-premises systems, and then we're doing research and compute on their own file servers at their universities. The problem with this is that this mechanism really isn't sustainable. It involves a lot of egress costs, as well as redundant copies of the data, and really kind of creating the siloed environment for researchers. So with moving moving these controlled access data sets to cloud-based systems like AnVIL, it really allows us to invert this and bring researchers to data in the cloud. And so this helps to reduce egress fees, make sure that we're hosting one copy of the data and bringing people to the cloud to allow them to collaborate together and be able to have an analysis environment that they can share their tools and analyses. AnVIL is made up of a few key components, and so we kind of think of these components in managing both data and then analysis. And so you have Terra, DocStore, Bioconductor, and RStudio, Galaxy, Jupyter Notebooks, and Gen3. And so we'll touch briefly upon each of these. I'm mainly going to be focusing on the data-based components of AnVIL. And then just to say that AnVIL is built on the Google Cloud Platform, and in addition, it is a FedRAMP moderate authorized system. And so the dotted line represents a security boundary where we're leveraging data access and controls that have been created by Google Cloud and implement that in AnVIL within our workspaces. In addition, the AnVIL covers all of the cloud storage costs. And so researchers and users coming to the AnVIL would just need costs to cover compute and then to store any downstream generated files that would come from their analysis. We do have the ability and option to egress the data, but we do require users to pay for that egress. We've set up AnVIL so that the underlying Google buckets of the workspaces are request or pays. So we ask the user to cover those egress fees. And since AnVIL is based on Google Cloud, researchers would need to have Google Cloud billing account in order to be able to do any of that compute or egress that I mentioned. And then finally, as I mentioned before, with building AnVIL, we're really trying to build a community where we have many of these public open access data sets. As I already mentioned, 1,000 genomes. We also have telomere to telomere. There's the Human Pangenome Research Consortium and others. And by bringing together Broad and Johns Hopkins, we're trying to bring together both the ability to support the infrastructure and data storage for AnVIL and its data sets, as well as provide outreach and training to the consortium and programs that are bringing their data to the AnVIL, as well as other groups that are interested in using AnVIL. So now I'm going to segue into talking more primarily about data and how data is organized in AnVIL, and just kind of briefly highlight how you could bring data to AnVIL if you'd like. So again, to just briefly outline what are the modular components of AnVIL that make up the data part. Go into the AnVIL dataset catalog and how that can be used to find and search for data sets. Go over what an AnVIL workspace is, and then, as I mentioned, kind of how would you upload and bring your own data to AnVIL. So for the modular components of data, the main two that I'm talking about are Terra and Gen3, which are the two at the top. So for AnVIL, we have the data organized in a workspace, and as I mentioned before, we have the Human Pangenome Research Consortium. So this is a public open access workspace, and the workspace both contains analytical outputs that were created by the consortium, done to process the files, as well as the primary genomic data files, as well as a minimal amount of phenotype data that's present on the subjects that were used for this project. In addition to Terra, we have Gen3, which is a system that was built and is maintained by the University of Chicago. And the way that Gen3 works is it allows a user to go in, build a synthetic cohort based off of data sets that they have access to. And then they're able to take that, the data instead of, samples that they want to do analysis on, and bring that back into AnVIL to do analysis. Finally, we've also been working to pilot Duos, which is data use oversight system, which is a product that's been in development by the Broad. And we're currently piloting the use of that both to review data access requests that come in through dbGaP, and kind of compare the algorithm that underlies Duos and how well that does against data access committees and their decisions on these data access requests, as well as consider using it to do study registration in addition to dbGaP for new consortium that are coming on to AnVIL, such as Gregor. So as I mentioned, we have a data set catalog, and so this is a high-level view of the data that's in AnVIL. So right now we have about 4.5, that should say petabytes, not terabytes, 4.5 petabytes of data in AnVIL. We have 485 cohorts or workspaces that contain data across the various NHGRI extramural programs, like the ones listed here, in addition to the open access data sets that I've already mentioned. So I was just going to briefly take you through the data set catalog, how you might use it, and find information on data that's currently in the AnVIL. So yeah, this is a good feature for how you could find data in AnVIL if you don't already have approval to go in and access the data. Since the data, besides the open access data sets, is all controlled access, in order for you to go in to the workspaces, you would already have to have an approved data access request through dbGaP in order to be able to go in and look. So this kind of gives you a summary of metadata that's available on the various studies. So you could kind of make a decision on whether you would want to put together a data access request through dbGaP. So here, this is just highlighting the consortium that have data currently in AnVIL. And so let's say that I wanted to pick, I'm looking for samples that are part of the Center for Mendelian Genomes. So I've now filtered off of that, and then I've also filtered off of data type. So I'm looking specifically for exomes. So what you're looking at here is you can see the total number of cohorts, the number of samples and participants, as well as the total data size. And below that, which is a bit cut off, but you'll be able to see on the next slide, is the set of workspaces and studies that are related to this results. And so you can export this as a TSV, and this would give you like the full list of what that would look like by a workspace, as well as a dbGaP study, and then the number of samples and the data. So if you wanted to find out even more information about the study, you can click on the study page, and this will bring you to something that is a representation of what you would see if you were in the dbGaP data browser. And this is showing the high-level study registration and information. And what it is displaying for statistics is the two cohorts, so meaning that this data is currently split out into two workspaces. AnVIL is organized by study and consent groups. We do this because our data access is managed at the workspace level. And so we split out the data into workspaces by study and consent, so we can ensure that we're granting the appropriate access to researchers that are coming in through dbGaP. And so, from here, a researcher could click on request access and it would bring them right to dbGaP, so they could put together a data access request. So now that I've kind of showed you how you would search for data and how you could go and apply for access, I'm going to take you through the AnVIL workspace. The workspace is made of a few tabs. I'm mainly going to focus on the dashboard tab and the data tab. Notebooks and workflows really ties into the analytical components of AnVIL and Terra, and that will be really highlighted in Stephen's portion of the talk. Okay, great. So the first tab that we have is the dashboard, and this is kind of really just showing at a high level what data and what information is in this workspace. So again, I'm showing you now the workspace that was pulled up, that was part of the Baylor Hopkins Center for Mendelian Genomes Center. And you can see that there's 803 subjects that have exome sequencing data, and as part of the dbGaP study, PHS 000711. And so you can see that NHGRI is a data custodian, and what the data use limitations are for that study. So IRB means that you would have to have a letter of an IRB letter of approval when you go to submit your data access request. So up here is workspace information. This information is automatically generated when the workspace is creation. It gives you an idea of when it was created, who owns it, what your access level is for this workspace, and then estimated monthly costs. Tags are something that we use to tag the consortium and dbGaP study IDs, so that way we can pull the information into our AnVIL dataset catalog. And then finally, in this corner, we have the Google bucket, which is a unique identifier of the underlying bucket of the workspace where all of the data files are hosted. Okay. So yeah, the next tab of the workspace is data, and this is where we're storing the phenotype data and file references, and helps to kind of keep track of all of the data within the workspace. So you can see we have this structured by tables, and so this is pretty flexible. So if you're bringing your own data to AnVIL, you could really use like whatever data model you already have in place. This is the 1,000 genomes workspace, and so we have here, you can see a participant, pedigree, QC result sample, sample and sample set. And so, the important thing is within the table, you want to ensure for participant and sample, and for any of the workspaces, you have a unique identifier that's used as that primary key and that data table. And then you can see here, you have this file reference path. And what's useful about having the file reference path built into the data tables is you could then select the the rows within the table, and you could bring that into downstream notebooks and workflows, which we'll show later. And so uploading your data to AnVIL is pretty simple. You could either open up the Google bucket in the browser, and so it would pop open the Google Cloud Console. And you can see here this bucket identifier that's also present in the workspace. And you could either upload files, or you could create subfolders if you wanted to organize the data and drop like your genomic data files or your analytical files. And in addition, you could open up, if you can see, we're back in the data tab, and you can see here under files, there's this option here where you can select the files and upload them, or you could simply drag and drop them into this tab of like the workspace. Okay. So I'm going to briefly highlight the analytical components of AnVIL, and then I'm going to pass it on to Stephen. So for this figure is what I've been showing before. So you can see that for the analytical components, we have Terra, DocStore, Bioconductor, RStudio, Galaxy, and Jupyter Notebooks. All can be used within the AnVIL environment, and they're all within our security perimeter. Okay. So this is an example of a featured workspace that was set up by the user education team at the Broad. And what it's describing is how you would run a variant analysis for a tetralogy of fallout. And so what's nice about these featured workspaces is that it provides an overview. It provides the research that the analysis tool is based off of, and it also provides you with preloaded notebooks and workflows that you can run to execute the same type of analysis. In addition, in AnVIL and in Terra, we have a library that has this showcase and tutorials, so you can see where the featured workspaces are, and also examples of the genome analysis toolkit workflows that you would want to run, maybe for joint calling or for copy number variant calling and things like that. DocStore is a tool that also is tied to AnVIL, and so it really allows researchers to document and organize like their analytical tools into a workflow, and then it allows them to share that with other researchers. Jupyter Notebooks is also running within Terra or within AnVIL. This is showing a Jupyter Notebook that we used for genome data that came in for the Center for Common Disease Genomics. And so what you can see is that we put in we ran this notebook to generate a set of QC metrics, and then you can see the output of running the notebook is a set of histograms that were used for us to do an assessment of the metrics and then establish a threshold cutoff so we could determine what was pass-fail for QC. In addition to those, we also have RStudio and Bioconductor, which are free open source, open development software. What's great about these is that it has preloaded software packages that a researcher could come in and just start using rather than having to try to develop like their own analytical workflow. And then finally, we also have Galaxy. The great thing about Galaxy is that it has a very large user community. So there's a lot of support that can be that you can get for running these tools and packages. And Galaxy is also something that you're able to launch from an AnVIL workspace. And I think this year into next year, we're really looking to extend the AnVIL. Part of that includes working with other researchers and analysts to bring in additional applications and tools. So we're working through a process of defining a process for verified third-party applications where analysts or researchers could use our APIs and develop a way to integrate their tools an application to have that, again, run within AnVIL. Because this is controlled access data, it does have to run, for applications, it does have to run within AnVIL itself to, maintain that security perimeter to ensure that we're, protecting this controlled access data. And then finally, we have these portal resources. So this contains a lot of tutorials for the various tools and applications. It also contains workshops that we've done in the past. So it's a place you can go and you can learn. And we have various learn profiles if you are, say, a data submitter, or you're a principal investigator or an analyst wanting to come into AnVIL. We have a getting started and, how you would go about running and launching these applications. And with that, I'm going to turn it over to Stephen. Stephen, did you want me to run it, or did you want to take over control?
I'll take over control, if that's okay.
Yeah.
All righty. Hopefully you can see the screen. Oops. Okay,
Yeah,
wonderful. So I'm very happy to be here and show you all a little bit about the AnVIL platform. And we're going to take a deeper look at some workspaces in AnVIL. We'll have a look at some data and some pipelines we can run to process our data. So for this section of the talk, I'm going to review some overview of key concepts, such as workflows, workflow description language, or WDL, and the workspace and the workflow tab in particular. We're going to get to know this tab very, very well. And there's going to be a demo where I will show some of the finer details about how to use the platform. So the use case that I'll present today is based on a clinician or a clinical scientist running some analysis in AnVIL on Terra, the compute engine. And ultimately, the goal here is to load some data into Seeker, which is an application on AnVIL. So in this particular use case, we're going to start out with a situation where a clinician or a researcher has a CRAM file, and they want to get that into Seeker to do some analysis. Unfortunately, it's not that easy, because Seeker accepts multi-sample VCFs. One good thing about AnVIL, as well as other platforms, is that we have access to the Genome Analysis Toolkit, or GATK4, which is particularly good for creating multi-sample VCFs. And those can be brought into Seeker. But unfortunately, GATK does not accept CRAM files. It accepts unmapped BAM format. So we can do a couple of sequence format conversions from CRAM to BAM, then BAM to an unmapped BAM, and then we can pass that into GATK to get our multi-sample VCFs into Seeker. So what we'll review today is a publicly available workspace in Terra that will cover how to do some of these file format conversions. And then we'll also take a deeper look into GATK about how we can do how we can create these multi-sample VCFs needed for Seeker. So what does GATK do? I think that we heard a little bit about this from Aaron Riggs, but at a very high level, what we're going to do is we're going to pass in a list of unmapped BAM files for processing for variant discovery, which will spit out a BAM. We'll pass that into a haplotype caller to get GVCFs. We'll pass those GVCFs into a sample map to get a sample map. And then we'll use that for joint genotyping to get our VCF, and then we can get into Seeker. Okay, so a few things. Candace did a wonderful job introducing the workspace, and we covered what the dashboard is. And this is the dashboard for the sequence format conversion workspace we'll use. Here's the dashboard for the GATK workspace that we'll use. And Candace pointed out some of the tabs. Particularly, we're going to take a look at the workflow tab. And on the sequence format conversion workspace, there is a number of workflows that have already been brought into this tab and already programmed to help you get running. The workspace, the workflows that we will be using in particular today for this example use case is cram to BAM followed by BAM to unmapped BAMs. So we'll take when we click on one of these cards, one of these workflows, we'll be brought into this form, and we'll go over how to use this form to get our processes launched. And one thing that's really important to point out is that the workflows that we will review today are based on WDL, or a workflow description language. This is a script that one might think of as being similar to a bash script, in that it has some defined elements such as a workflow, a task, a command, an output, and a runtime. And here is an example workspace of an easy puzzle that I encourage everyone to look at if you want to know more about WDLs. And this will help you understand the different aspects of WDLs. Unfortunately, we don't have time to review that today. So we're gonna instead start off with cram to BAM and then BAM to unmapped BAMs. And as Candace mentioned, a lot of WDLs can be found, or workflows can be found on DocStore. And these are links to the workflows on DocStore. Importantly, on DocStore, once you find a WDL that is that will be important for your work, you can simply click this button that says AnVIL, and then that will help you push the workflow to your workspace where you can do your analysis. So, of course, as I said previously, the ultimate goal is to get our analysis into Seeker. And so to get there, let's jump into Terra. Let's jump into AnVIL. Let's see what this is all about. Okay, so what I'm showing right now is the Workspace dashboard, and this is for sequence format conversion. The dashboard will give us a lot of information about what the converters can do. We have some information about the workflows. We're going to look at, and there's a lot actually. We're going to look at cram to BAM. There's some information about how to run this, how long it might take, and how much it might cost to run. The data in this workspace is quite sparse. There's a single sample. It's a sample from the 1000 Genomes Project. So this is an open access data. And NA12878 is a very famous sample from this, from the sequencing project. And I understand that this individual is the most sequenced human on Earth. Okay, so what we have in this data table is a bunch of files, but what we're really interested in is this column here named CRAM, which has a link to a CRAM file. We will use this link in this data table in our workflow. So let's jump over to the workflow tab and take a closer look at this cram to BAM WDL. Clicking on that will bring up the format, the form to get everything running. So I'm gonna hide the optional inputs. And one thing that we can see here is this .cram. This is an input cram. When we see this, that's a reference to the table that we're going to be drawing from. It's a sample table, and we're going to draw the .cram files out of there. We see some outputs. We're going to get an output BAM and a BAM index, as well as a validation report. So the first thing we got to do is select our data, except we cannot do it here. I do not have the permission to modify this workspace. This is a publicly accessible workspace that I do not have access to. But this is not the end of the road. What we need to do is make a copy of this. This is a workspace that is read-only. So we can click these three dots in the upper right-hand corner, and then we get this button called clone. This will create a copy of this workspace that will be private to the cloner. So this will be a workspace that is private to me, unless I share it, which I can do. When I click clone, we get this form that helps us get set up. So we know the workspace is sequence-format-conversion, and it appends space copy. It's not particularly informative, so I'm going to rename that H3Africa demo, and then maybe a date. What is it? 2022 It's the 4th month, the 6th day. Okay, the next thing that we're asked is to connect some billing. We're gonna run some workflows here and they're gonna cost money. So how are we gonna pay for this? I have a number of billing projects already created and I'm gonna use one that's ready to be used for the AnVIL outreach working group. So now that I've got a workspace name and a billing project, that's enough to get cloning. So I'll click clone this workspace and a copy of this workspace is being made. You can see here, my access level is currently reader. And as this comes up now as a clone, I am the project owner. So I'm the owner of this workspace. I am now free to compute on this workspace. So let's come back to this workflows tab. Let's come back to our cram to BAM. We see that the input cram is this .cram, cram coming from the table in the data section. We're going to pull the data from the sample table, and now we're going to select it. There's a single file here. We'll select the single file. If there are multiple files, you can select the specific ones. But for here, in this point, we have one. So, okay, we have the inputs, we have the outputs. The outputs are going to be written to the table, the sample table, and we're going to create a new column called output BAM index, a new column called output BAM, and a new column called output validation report. Let's get this analysis running. We get this pop-up that confirms that we do indeed want to run this. We're going to run it on Cromwell 78, and it's going to launch a single analysis. Let's launch it. And the analysis is launching. Let's give that a second to do its work. 2 seconds.
Stephen, are you going to make this workspace public once we're done with the demonstration and presentation? I think people are interested in being able to look at it afterwards.
Understandable. The workspace that I have cloned is already publicly accessible.
Okay.
And the workspaces are linked in the slides, which should be made available to you.
Okay, great. I linked to the original workspace that you've cloned.
Perfect. Thank you, Candace.
You're the one you're working off now and link it.
Okay. Thank you, Candace. So after launching this workflow, we see that the workflow is queued. If we refresh, we should be able to see that the workflow is then submitted. Oh man, it looks like the connection is not so wonderful today. Here we go. Getting closer. Okay, so we see that the workflow is submitted. Now, this workflow is quite lengthy. It will take perhaps an hour or so. So we don't have enough time to sit here and wait for this to run. What I can show you is some work that I had done prior to today. I did this work on the 5th. And when the cram to BAM workflow completes, we get this check mark that it's done. We can click on the workflow and get some ideas of what happens. We can see what the sample was that was run. We can see the workflow. We can see submission ID and that it succeeded. We can see that it was launched at 3:43 and finished at 3:54, so maybe 10 minutes. I overspoke when I said it took an hour. Okay, so now we've got this run. We can come back and then run our BAM to unmapped BAM workflow. This will be very similar to what you saw previously. We'll select the data. Now we again will select NA12878 as our input. This time, there's a single input and the variable is input BAM. And the input BAM, interestingly, will be the BAM that was outputted from the last workflow. So our cram to BAM output is what we're going to put in for the input to the BAM to unmapped BAM. When we look at the outputs, we can see that we will write the result to the table, the sample table, in a column called output unmapped BAMs. Okay, we're ready to run. Again, we're going to run with Cromwell 78, a single sample, a single analysis, and we're ready to do it. Let's launch. Okay, so this will eventually submit the job for execution, and pardon me. And when it's pardon me, we can see that this has been submitted. And we can also see from the previous work that I had done yesterday that it does run. Again, clicking here, we can see that the process succeeded. And so now in the data under sample, we have, scrolling through, this is our output BAM index, our output BAM, and we have a list of unmapped BAMs now. So now that we've got unmapped BAMs, we can push this, we can push these data points into our GATK analysis. So let's move over to this GATK analysis workspace. I'm not sure, I haven't been monitoring the chat. I'm not sure if somebody was able to share this workspace in the chat. I've done it just now. Okay, so in this workspace, we again land at the dashboard. We see that this is GATK's best practice for germline SNPs and indels. There's an associated notebook with this workspace. We will not use the workspace. We will use the workflows directly by running, executing the WDLs. So we see that there's a number of workflows. As we reviewed before, pre-processing for variant discovery, haplotype caller, generate sample map, followed by joint genotyping. There is a number of workflows set up for the genome build for HG38, but they're also duplicated for build 37. Today, we're going to look at HG38. Since we want to do joint calling, we're going to need to pass in more than one file. We have NA12878 as unmapped BAMs. We'll use some additional unmapped BAMs from the 1000 genomes workspace. Some samples from 1000 genomes that are linked to from this workspace's data table. So if we scroll down on this, we get some specific instructions about how to run the workflows. And then we get some additional information, continuing to scroll, about how long it's going to take. This workflow for running NA12878 is going to take an hour and it costs about 18 cents. There's additional information for all of the workflows that we will run, all 4 of the workflows we will run. So, okay, let's take a look at the data. Looks like it's taking a brief moment to populate the data tables. And here they are. Okay, so we've got one sample set and it's got 50 entities. The 50 entities are the 50 samples from the 1000 genomes project that I had mentioned. However, we don't want to analyze 50, we want to analyze 51. So, oh, pardon me. Here are the 51 samples from 1000 genomes. And at the bottom of this list is NA12878 that we have used in the past. So here is the flow cell unmapped BAM list. So here's the unmapped BAM list for NA12878, what we needed to get into GATK. So let's do that. Again, there's a number of workflows pre-populated in this workspace. We're going to look at those, as I mentioned before, for HG38, 1-1, 1-2, 1-3, and 1-4. The rest we will not touch today. So let's jump into this first one, pre-processing for variant discovery. I will hide the optional inputs, but we will see that there is quite a number of inputs needed for this workflow. What we can see here is flow cell unmapped BAM list is what we need to put in. The attribute here is this downsampled flow cell unmapped BAMs. We're going to pull from that data table. I'm just realizing right now I have not yet cloned this workspace, so let's do that. Again, I cannot operate out of the read-only workspace. I have to create my own copy. Apologies that this is taking a few seconds to populate. While we wait, we might as well come over to this one that I've already cloned. Okay, so we are back at the same form, pre-processing for variant discovery, HG38. We've got our inputs of the BAM list. Let's select the data that we want to run on. Selecting the data, here we see not just one sample, but 51 samples from the sample table that we looked at before. Let's select all of them. Okay, so now we've selected all the data. In the outputs, we see that we'll create an analysis ready BAM, and we're going to store that in a new column called downsampled HG38 BAM. We're going to get a analysis ready BAM index, which we'll store in downsampled HG38 BAM index. And there are some additional samples that we can add to our table if we want. For this example, I'm just going to press run. This is going to launch 51 analyses. So one thing that I want to point out is running 51 samples is as quick as running a single sample. This is part of the power of WDLs and their massive scalability. One can as easily run 51 samples as one samples or 1,000 samples or even more. So now we see that there are a number of queued analyses, and importantly, our one sample that we want to add to these 50 for joint calling, NA12878, is there. Okay. As we saw, this is a process that will take over an hour. So looking at the job history, we can see that this completed nicely. You might see that when I went to run 1-2 haplotype caller HG38, there's an error, and I aborted. What I ended up doing was I ended up running this workflow before this one finished. I wasn't going to show this, but it might be useful. So what we see here is this sample failed. It had this one particular sample had not yet run. And we get the error output. It expected a single value for workflow input, but evaluated result set was empty. It didn't get passed in because it hadn't finished running. So what I ended up doing was running it again. Okay, so now that we have finished 1-1 pre-processing for variant discovery, the next step is the haplotype caller. This is the one that failed when I ran it too early. So again, we're going to come here and select our data. We're going to pass our data in through the data table. Select the data. This time we can choose a set of samples. So we can choose the 51 entities. So what this is doing is it's remembering the samples that we have selected. This is particularly important if you've got a sample set of 1,000, but you have 25 in particular that you want to run. It will remember the 25 that you want to use based on the last analysis. You say, okay, I'm selecting that. We're going to have to pass in the input BAM, which is the downsampled HG38 BAM that was created from the previous run. We'll also pass in the index. The outputs will be pushed to the same sample table in a downsampled GVCF. So we'll get a GVCF out of this, as well as a GVCF index. We're ready to go. Let's run it. It's going to launch. And I think that probably by now you might be getting a little bit of the flavor of how these workflows work. The output of one workflow is the input of the next. We're in the process of launching the second. We will have completed the second. When it does, when it does complete, we will see in the job history that it has completed. Wow, it's particularly slow today. Okay, so when this is completed, we will see the haplotype caller has completed. We can take a closer look at how this was run, at the results. Oh goodness, it's queued. I thought it had finished. Maybe I'm looking at the wrong space. So what I'm going to do now is I'm going to switch over to some screenshots of what I had taken of this process in the event that something was going wrong. Here we go. So here we see the result of submitting the haplotype caller workflow. We see that all of the samples are running, all 51. We have submitted 51 samples, and NA12878, our key sample, is running along with it. Yeah, when it's done, it'll show that it is completed. And we can see that they've all succeeded, all samples. Stepping on to generating the sample map, this one was quite a bit quicker. We then come back to our workflows tab, select the generate sample map workflow. We'll select the data as we had done previously. This time the inputs will be the sample set ID, sample set, and the downsampled HG38 GVCFs. We'll select the data again as previously. We'll select the 51 samples that we want to analyze, and then we'll click Run Analysis. We'll again see that this is submitted for analysis. It goes from being submitted to queued to running to completed. When it completes, we will see the check mark that everything is done. And then we are on to our final step, joint genotyping. We'll go back into our workflow tab. We'll select our workflow card, 1-4 joint genotyping HG38. And this will all look very familiar. We'll select our data. We'll input our starting point through the form. Select our data, again, the 51 samples. Here we'll see that the results will be pushed to tables sample set. We'll get a number of new columns. Of importance here is our output VCFs. This is the file that we will use to load into Seeker. And here's the index. So we'll run the analysis. We will see that it gets queued, finally run, and then after a number of hours, it will complete. All right, so now we can see that we have run all 4 workflows. We completed our job. That's wonderful. So when we come back to the workspace, we look in the data table and the data tab, and we look at the sample set table. In this top row, this is the 51 samples, the 50 samples from 1,000 genomes, plus the NA12878 that we've added additionally. And we get one outputted VCF file. When we click on this link, one item, we get a pop-up. The contents, we get a link, a GS link that brings us to the workspace bucket under a particular folder, another folder, and final folder, and then we get the result, 1-1, preprocessing for variant discovery, HG38, a date, and VCF. That's our VCF file. So we can use that link to egress that file if we want to do some local analysis, or if we want to use that for analysis in AnVIL, like let's say pushing it to Seeker, we will use that file locally on the cloud. We don't have to egress it. We can keep it in AnVIL, and we can push it to Seeker. So how would we do that? We would come to this files space, which will bring us to this kind of browser of the Workspace bucket. So under Files, in this folder structure, in the final folder called Call Final Gather VCF, we see that there are two files, a VCF file and the index of that VCF file. Those can then be passed into Seeker. You'll notice in the top right, there's an Analyze in Seeker button. We'll use that to get into Seeker, and that's where I'm going to stop. Tomorrow, we'll hear more about Seeker from the experts of how to run this application on AnVIL, and that will conclude the demonstration. So now, as Candace had done before me, I'm linking to a number of resources here. There's a number of resources I'd like to point out to get help. Again, pointing out the portal. We have a book that's called Getting Started on AnVIL. If you want to do this in AnVIL, and this would be great for the work that you are doing, we have an opinionated guide about how one might get started. We have a discourse forum. If you have questions and you want to get help, you can come here and post your questions. We've got a dedicated team waiting to answer your questions. Additionally, we host monthly office hours. So the AnVIL outreach team is willing to hear your questions and address your questions and provide the support you need to get the work done that you need to get done. So we're excited to see you come and drop by our office hours. Recently, the AnVIL platform was published in a paper describing the AnVIL platform was published in Cell Genomics. You can go ahead and follow this link to download and review some of the aspects of AnVIL. I've also linked some documentation for GATK and a GATK specific forum if you have very specific questions. The links to the workspaces that I think were shared in the chat. I know I posted at least the GATK workspace. You can find those here. These are both publicly accessible. And you can then follow along on your own. So I want to say thank you all for taking the time to join this call today. And at this point, I'm going to stop sharing and wonder if you have any questions.
There was one question, Stephen, about converting a BAM or a CRAM to a FASTQ to start at the beginning to process it. I didn't notice that option in the sequence file conversion, so I was trying to see if we could find something on like GATK that we could send to people.
I see. Okay. On this, did you mention there is going directly from FASTQ to which?
They want to start with a CRAM or a BAM and then go to FASTQ. I don't know if maybe because they would want to reprocess it. Heidi has her hand up too.
I know that we can go from interleaved FASTQ to paired FASTQ to an unmapped BAM. I'm not entirely sure about bringing that to a CRAM and then back, unless I've misunderstood the question. Heidi, did you have a question or something to add?
No, my computer crashed right when you finished and I was about to help moderate questions. But then when I had to log in through my phone, I wasn't allowed to speak. So
Oh, no.
Sorry, I'm working on restarting my computer. But if Candace, you want to continue reading questions from the chat, that's probably best for now.
Okay, great. I found something here that looks like it might do what one of the participants asked, which is starting with a BAM or a CRAM to convert to a FASTQ. Hopefully that's helpful. There are also some questions about trying to get started. So if you don't have a Google billing account, there is the option of free credits from Google. It does require the use of a credit card, which, you know, I get could be like scary and wanting to enter credit card information, but that is the way to work around not having a Google billing account. And I did hear back from Terra support, and they said you should put down that it would be for personal use, not business use.
Great, thank you. I did that. So yeah, so a lot of my question is very, very basic, and it's on setting up the billing. And so we actually have 2 billing accounts, correct? So we have one which we set up with Google Cloud Platform to get that credit. And the other we need to set up in Terra itself billing to connect that together, correct?
Right.
Okay.
Correct. Yeah, so there's like Terra has a Surface account that has to be added as a user on your Google billing account. So then when you log into Terra, it will then see your Google billing account, and it will allow you to create a Terra billing project off of that. So I'll try to find the article that describes adding that service account to your Google billing and allow you to bring it into Terra.
Great. Yeah, I've seen some of the support pages and walking through it. So I just have to say, full disclosure for me, first time doing this, and I am at the point right now of creating the billing in Terra. So just if anyone else is, I'm just letting everyone know that's where I am from a total novice user for this.
Well, I would say that's already a great head start, and I get that it's a bit confusing with like billing account versus billing projects. So I think you're already in a really good place.
Okay. I'm posting into the chat help@anvilproject.org. This is our discourse forum. If there is nothing else that you take away from my presentation today, this is a wonderful, wonderful one to walk away with. This is where you can get your questions answered. This is how you can get your how-to solved.